Welcome guys, this is GK from GK Marine Tech. This is our first lecture regarding we have started with electricity, which is very important topic in marine as well as the shore. So after this we are going to see the basics first, so that we will get a good clarification about the basic fundamentals and units and how to measure what is the difference between voltage and current, everything. Okay, so we will get it in the topic. So first, normal electricity is passed through some conductors, right? This conductor is made of molecules, and you know that molecule is made of number of atoms. The copper is having its own atom, like aluminium is having a own atom. What is the difference between these two atoms? There is a number of protons in that. How many number of protons is there? That element will vary. So for example, copper, it is having a 29 proton is there. Like silicon, if you take it, it is a 14 proton is there. And if you take argon, it is having 18 proton is there. So depends on the number of protons, that element is varying. This is arranged in the periodic table, you know that. Okay, now how the atom is arranged? Here we have a three elements: proton, neutron and electron, right? Proton is a positive charge and neutron is not having any charge, it is a zero charge. Neutral charge, you can say it is a neutral charge, and electron is a negative charge. So what is this charge? It is similar to the magnetism having a north pole south pole, isn't it? Same way in electric field we are calling it as a negative charge and positive charge. So similar like a magnet, this also same pole, same charge, like a minus charge and minus charge will repel, and opposite charge, plus and minus charges, will attract. Okay, similar way. And electric field, you can make it as a magnetic field, and magnetic field you can make a electrical field also. This is all future we will talk about detailedly. So first how we will see how the atom is arranged, then we will see what is the electricity. Everybody is saying electricity means flow of electrons. So in short time we will come to know it is right or wrong. What we are saying, flow of electron, is right or wrong. Okay, so current means what? It is a flow of electrons or what? That one we will come to know. Okay, we will see that atom arrangement. The center portion, all the proton and neutron, is a heavier particle. Heavier in the sense it is 2000 times heavier than electrons. That means electron is a very tiny particle. So we are consider about the electron only. Electron only we can handle. This heavier particle, proton, neutron, we cannot remove from the atom. Okay, we cannot move from the atom. So these two will be in the center portion. And one more condition will be there, all the atom. How much proton is there? That is called positive charge ion. How much proton is there? The same amount of electron will be there. Then only that atom will be neutral state. Otherwise, if it is electron is more, it will become a minus ion, or if proton is more, it will become a positive ion. Okay, you heard about the ion. We will talk in the battery section. So if it normal atom, if copper atom, it is a ground state, it is a neutral state, stable state. You can say it is a stable state, means number of electrons should be equal to the number of proton. Okay, so how it is arranged, that is very important. In that arrangement only we can distinguish the conductor, insulator and semiconductor. These are three important categories in the electron movement. Okay, so which atom we can move the electron, or which atom we cannot move, which atom will be semi condition, it move or may not move. So that one we will see. First, how it is arranged, you see, all the proton and neutron will be in the center portion called nuclei, and around that I made it as a circle. It is not a circle, it is a shell. It is like a sphere. It is a path, it is an orbit. You can call it as a shell. So this shell, in the shell orbit only, shell path, you can see it's a path. This path only the electron will be keep on revolving. Electron will be not in the stable static condition. It will be revolving around the nuclei, like Earth, planet and all revolving around the sun. Like similar way, this nuclei will be in the center. Around that, the electron will be in the revolving condition with the speed of light, which the speed is equal to the speed of light. That much fast it will revolve. Okay, so first I will take it as a copper atom. Copper atom it is having electron 29. That means proton will be 29, neutron will be 29 or 30 or depends on that. So that may be different, but proton and electron will be same. So proton will be 29. Already I put it in the center. So electron, I will put this small blue color ion is an electron. I will arrange one by one. The arrangement is also having some formula. So first orbit, this orbit is called K shell. This orbit is first orbit. First orbit will have number of electrons will be number of electrons will be 2n square. 2n square. This is the formula they found. They, after innovation, they found this. This is the method formalized how the orbit is distributed. The electron is distributed in the orbits. So first orbit will be in the 2n square. N is the number of orbit. First orbit is 1. So 2 into 1 square, it is a 2. So we will keep 2 electron in the first orbit, that is a K orbit. So only 2, it is a very closer orbit, so that only 2 can fit all atoms. Okay, so another shell, how much will be? 2 into number 2 is the orbit, 2 into 2 square. 2 into 2 square is 8. So next orbit will be 8. It may be equal or because it will keep on revolving. So approximately I will keep it equal. How many has come? 6, 7 and 8. Okay. Little bit will organize. So second orbit, it has become 8 electrons. So in few minutes you will come to know why I am saying all those things. For studying electricity, what is the necessity for marine engineers, why we should know this much detail, you will come to know in few minutes. So next orbit, you can tell 2n square, 2 into square. So 2 square is 4, 8, right. Third orbit will be 3 square, 3 square is 9, 9 into 2, 18. So the third orbit will be 18. I will keep it 18. Pieces, 18 electrons in the third orbit. Okay, so third orbit will be 18, little bit center will keep it. Okay, so first orbit will be 2, second orbit will be 8, third orbit will be 18, so remaining only 1. In 29, if we minus all these electrons, only 1 is left. 1 we will keep it in the outer. So the outermost circle is called valence electron. The electron which is lying on the outermost orbit. Outermost orbit depends on this. This is having a 4 orbit. Some element is having 3 orbits. Whatever it is outermost orbit. How many electron is there? That is called valence electron or free electrons. So that electron we can move from that orbit because it's very away from the nuclei. It is having a, and also it is having a repelling force is there, so that very easily we can move from the electrons from the atom to other atom. So if it is moved to the other atom, we are going to see move to other atom, what will happen? That atom will receive, but it will not keep it because it will become more negative. So for making it balance, it will push the another electron. It's having one electron already in the orbit, it will push the electron to outside. So in that way, if you started pushing the electron, the electron will keep on moving from the atom to atom. That movement of electron, it is called electricity, correct? So, but we should not, I told you what is meant by current means it is not a flow of electron, that is a wrong answer. So there is a moving of electrons, electron is moving, but why we are not calling it as electricity, that we are going to see. So this is the copper atom, this is copper atom, 29 electron. Twenty-nine electron, negative charged. Okay. Now this is a good conductor because this electron, free electron, very easily move from one atom to another atom. This is called a good conductor. Okay. Now insulator. We will come to the insulator. Insulator, we will take a sample argon. Argon is 18 electron. 18 electron is argon. So argon is the insulator. Okay. So 18, how we can arrange? First orbit, it is named as a K. K is 2. L orbit 8. And KL, M orbit, third orbit, 18 minus 8 minus 2, it is 8. Okay. So shall we convert this one into argon? Very simple. We can remove all these 18 atoms. Okay, these 18 atoms we will remove. It's not required. So we are making this atom into argon now. Proton already arranged in 18. So electron I am going to arrange. So this third circle also will have 8, right? So we will keep it 8. Remaining atom we will remove. How many is there? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this atom is called argon. So here this one we can remove. Okay. This one we will remove it. Okay. So this is called argon atom. But outermost shell, this is the valence shell. Valence electron, how many is there? 8. If it is more than 4, remember the outermost circle, the number of electron, it is more than 4, that means insulator. That is why some metal it is passing the, like copper, aluminium, iron, passing the electrons. Wood, glass, mica, rubber, they are not passing the electron. Because of that, its outer circle, outer valence electron having number of electron is more than 4. Okay, more than 4, it is insulator. Okay, so this is like we cannot remove the electron from that. Okay, now we will come to the semiconductor. That is a very important role of electricity. It is very much improved because of the electronics. Electronics purely depends on the semiconductor. Semiconductor in the sense it is between insulator and conductor. Okay. So semiconductor we can take it as a silicon, germanium, carbon, whatever, but silicon we will take it. That is a familiar semiconductor we are using nowadays. So silicon, how much it is electron? Silicon, silicon 14 electrons. Remember, silicon is having a 14 electrons. So we will remove 4 more. Okay. 4 more electron. Okay. Now how much is there? Outer shell is having 4. So whichever the element is having a 4 electron in the valence circle, you got my point? Outer valence circle, which atom is having 4 electrons, That element is called semiconductor. Only three element is there: carbon, silicon, germanium. So silicon we will consider as a semiconductor. Semiconductor we will future videos we will talk about the electronics. In that time we will come to know. Okay. So initial stages I am drawing like this. After that I will explain with a good animation which is very easy to understand. First one, it is like a basic, like what we studied in the school days. So I made it like drawing in front of you only. So a little bit waste of time, but future videos I will try to show the no, explain with the animation, with the help of animations. Okay. So this is the atom, how it is structured, how the electron is moving from one to one. Okay. So now we will see, we will draw, we will remove all other things. We will take it only the two circle. For example, only two circle, only this first circle having only one electron, how it is moving from one atom to another atom. For consideration, we are making, for making easy, I am deleting everything. For ease understand, I took it one conductor, good conductor, which is having 4 atoms, and now I am going to pass the electricity in this. I am going to make the electricity in this conductor. How I am doing, you see. So already I told you electron is a negative charge and proton is a positive charge, and green color neutron is having neutral charge. So what is happening, you will see. We are going to move only electron, that is a negative charge. So what I am going to do, some external force, I am going to pull this electron out. So what will happen? This is become positive. This is become positive. I will write it. It has become positive. Okay. This is become positive. Correct. Because one electron is gone. Now positive charge is there. That atom become a positive charged. Positive charged. Now this will try to get it neutral, equilibrium, balance condition. It will try to get the balance condition. What it will do? It is lose already one electron. That electron will not come back. So it is taking the electron from the next one. It will pull the electron from here. So what is happening? This negative charge is going this side. The negative charge, okay. This negative charge is going this side. So what is happening? First negative charge was here. Sorry, negative charge went out. It is pulling from here. So the electron is moving this direction. So negative charge E minus is going this way, but positive charge, initially it was a positive charge. Now this become a positive charge. So positive charge is moving opposite direction. Okay. Positive charge is moving in the opposite direction. Now little bit you understand what I am trying to say. Electron is moving in this direction. Same time proton is not moving, but from the charge of the atom, it is transferring from one atom to another atom. Okay, that is the important thing. You have to understand the basic. So this is called, this is what is happening next. Now I am transferring here, then positive will become here, positive will become here. So positive will jump this side, electron is jumping other side. Now this electron, you take it this electron, and now the positive here. Got it? So electron is moving this direction. So we can call this is the minus port, minus port or terminal. This is positive, this side it is coming, we can call it as a positive. So this is like a battery or whatever you can say, a source, potential source, electricity source. So minus will be, the electron is moving this direction, but charges, positive charges moving in the opposite direction. Okay. So this charges is called as a current. This charges is called as a current. So now you tell me, what is meant by current? It is a flow of charges. Current means flow of charges. What charges? Positive charges. Correct. So we are not considered as an electron. The reason behind is this electricity first discovered by Benjamin Franklin, one scientist. He found the electricity source and he made a lot of equipment and lot of analysis and formalized and everything they have made. That time they are thinking positive charge is moving, and from that only current is passing from positive to negative, not negative to positive. But after later days, Joseph John Thomson, another scientist, he made a vacuum tube and then he found that electron is moving in the reverse direction. It is having a negative charge. In cathode ray tube experiment, he found physically they saw the electron moving from the reverse direction, and that electron is having a negative charge. So now the confusion, because already all the analysis, research, everything already done on the current basis, which is going forward direction. Now electron, they found electron, its negative charge, it is going in the reverse direction. So they accepted that one, but they don't want to change the pattern, how much we now research has happened. So we will continue with the conventional current. That is why it is called as conventional current. So positive to negative, conventional current will go. Negative to positive, electron will flow. But we don't, hereafter we don't tell electron flow. We are not considered as electron flow. We are considered only the current, which is the positive charges jumping from one electron, physically not transferred. That is why we cannot say that flow of electrons or flow of protons. Here no flow of protons, but flow of charges. Positive charges jumping from one atom to another atom, and is going towards the positive and positive to negative through the circuit. So hereafter, wherever we are studying, the supply current is coming out from the positive and going into the negative. But actually electron, if you see the electron is coming out from the negative and going to the positive. Okay. So now we forget about the direction of the electron. We will consider now in even battery or any source, DC source, the current is coming out from the positive terminal, going to the circuit, do the work done, what load you have given, then it is returned back to the negative side. Okay. So don't confuse with the electron. It is more electron in the negative side. So electron only moving in the direction from negative to positive. So how the current is going in the opposite direction. Don't confuse. Now don't think about the flow of electron direction. Now flow of charges. That is called current. Conventional current we are calling it as. Conventional current symbol is I. Okay. This is we are going to discuss about in another few minutes. What is this current? So it is only unit. So it is having a 2 units. One thing, we have to pull this electron, we need some force. That is called electromotive force. Correct? Electron, for moving the electron, we need some force. That force can be magnet or chemical or heat or light or whatever it is. Lot of sources we can move this electron outside. Chemical also. Okay. What the force we are applying? That force is called voltage. That force is called voltage. Unit is volt. Now you understand what the force is applied to pull the electron. That force is known as voltage, and that for that unit is volt. We call it as volt, and V is the letter represent for that. Okay. So that is called volt. Volt is, it is only the force, it is not doing any work. But work, which is work you are doing? This charges, this positive charges from here, that means current. This current is going this direction, this current is going to do the work. So now how much current is passing through one cross section? For example, this is the one cross section. This cross section, how much charges at a time in 1 second? In 1 second, how many charges passing through this? Okay, one electron is passing this side, means one charges is passing the left side. So how many charges? But it is a million of charges. So we cannot tell that number. It is a number around 6 point. Actually, we cannot no, so millions of charges is passing in at a small second, 1 second. So we cannot name it as a number. So what we are telling, so much bunch of electrons, we call it as one unit called coulomb. Coulomb. Coulomb means, this is C, this is the current measurement. 1 coulomb equal to 6.25 into 10 to the power of 18 electrons. 1 coulomb equal to 6.25 into 10 to the power of 18. 10 to the power of 18 digits. You imagine how much big number is. So electron is this much tiny. So this much millions of numbers, if you put it in the calculation, you will get no error, because your calculator will not do the 18 digits number. So 1 coulomb, they are what they did, this much big number they consider is a 1 coulomb. So 1 coulomb, how many coulomb is crossing? 1 coulomb is crossing in 1 second. 1 coulomb is crossing in 1 second. That is called 1 ampere. The current unit is ampere. Current unit is ampere. This is 1 coulomb per second crossing in one cross section, in one conductor. Okay, so this is 1 ampere means 1 coulomb means this much electrons has to move this side and this much charges has to move this side in 1 second. That is called current. Now you understand that the force is called speed. Speed of electron, you can say it's a speed of electrons. The force is actually going to the speed. So speed of electron, it is called as a volt, and number of electron, quantity, this is not a quantity, but current is a quantity. Quantity means this many electrons 1 second it is passing, right side, left side. Okay, so that is called ampere. So now you understand what is the difference between voltage and current. Voltage is the force. It can be present without current also. If battery, if you take it, positive side it is a high potential, negative side is a low potential. Voltage is present. If you measure it, 1.5 volt is there, but no current. Current for measuring the current, you have to pass through the conductor. So positive to negative, you have to make one conductor. So the current will start passing. So without current, voltage can be present, but without voltage, current cannot be there. Okay, but for increasing the current required, we need more voltage. Less voltage will not move more current there. So this relation you have to understand. This is not direct conversion, volt into current, current into, it is a directly relationship between voltage and current. So if you increase the voltage, you can increase the current, right? But if you increase the voltage, but with zero current also you can do it. Without current also you can do it. So it is having us like that relationship. In future videos, we will take one battery as a source and we will connect how to measure this volt, how to measure the next video we will do it, how to measure the volt, how to measure the current. Current measurement, there is no meter. Next video we will talk about this. There is no equipment to measure the current. Then how we are measuring? In ship you saw that ammeter and all. What is ammeter? We will discuss about in the next video. So I think this video little bit we will discuss about the basic, maybe little more, but this is a very must for people to understand what is conventional current, what is a flow of electron. We should not tell is a flow of electrons, we should tell is a flow of charges. Flow of charges in the reverse direction, positive to negative it will go. So now from atom, how it is structured, how the electron is moving from there, and neutron. And one more thing, this neutron, what is happening is inside full of proton is also same charge, repel each other. So between the protons, this neutron will act as a neutralize agent. Okay, so these all atomic structures, it is very important basics we should know. About deep, still more deep is there, but we don't want. This is enough. Yeah, easily you can understand how it is one conductor. Now this video, what are things we talked? How the atomic structure is assembled, arranged, and how the free electron, what is free electrons, how it is moving, and what is the difference between conductor, insulator, and semiconductor, and then what is the electricity. It is a moving of electrons, but we are not calling it as, we are talking about conventional current which is flowing opposite direction. So why it is opposite direction, I explained. So now you understand about the conventional current direction, why we are using the conventional current, and what is the ampere rating, which unit we are calling it as ampere. Ampere is the quantity of the electron, and the speed of the electron call it as a voltage, it is a force. So this is the things we discussed about this video. Next video we will discuss about some more basic, then we will get it in the system, what system we have in the ship. We will get it in the system and we will discuss. Continuously watch the video. If you are the new viewers, please subscribe this channel and continuously watch, share to your friends, so that everybody will get use of it, this channel. What are the topics we are discussing, and we will see in the next video. Thanks for watching.